Welcome. Let's solve polynomial equations. Well, first, let's look at some of the things about it and the basic steps or ideas with it. Solve means to find the zeros. Call them what you want, but it's to basically say x equals whatever those things are. So setting the equation to 0 is the first basic thing, because then you find the x's that make it 0. Factoring is always the best thing to do first, because it usually will help because it's easier to do than most of them. And if you can't do that, then you do the P and Q method with synthetic division and get a depressed polynomial and factor that, or use the quadratic formula. And actually, that's what's saying here. You keep unraveling until you have all the zeros, including imaginary ones, and you might need the quadratic formula with a second degree polynomial. And this is a good important one. The number of zeros matches the degree. Let's look at solving some basic ones here. All right. So this is where you have to remember your factoring techniques. So I'm going to start here looking and seeing that there is a common factor here of x. So I have a 3x minus 1 is equal to 0. They each get their separate zeros because they're factoring things. So we're doing the a times b equals 0 thing, where either a equals 0 or b equals 0 or both equal 0. So x equals 0 and 3x minus 1 is equal to 0. We'll add the 1 to both sides and divide by 3. So for this first one, the solutions are 0 and 1/3. For the second one, looks like I can do the same thing, but now it's not just taking an x out, it's also taking a 3 out. So I'm taking a 3x out of both, and I get a 4x minus 3 equals 0. And now we can do the same thing. Divide by 3, and we still get an x equals 0. Here I'll add 3, and then divide by 4. And therefore, these are our two solutions for that problem. 0 and 3/4. This next one, we're still going to do the same concept and start with taking out a common factor, and I'll change the sign here. And it looks like each of them, I can take a 6 out of each of them, as well as some x's. There's 2 x's here, but there's 3 and 4 in those. Well, that means I can take at least 2 x's out of each of them. And that means there is a common factor, and here I get 3x squared minus 4x plus 2 and equals 0. Now, what that means for me is I have 6x squared is equal to 0, divide by 6, and when we get x squared is equal to 0, what we do is we get a double root here. Okay, so there's 2 of them, so I can say when I divide by both, square root of 0 is 0. Plus or minus in front doesn't matter, but we have to remember that this is a double root, or it has multiplicity of 2. On the other one, we have to say 3x squared minus 4x plus 2 is equal to 0. I can't see a way to solve that in factoring, so I'm going to have to use the quadratic formula. And in using the quadratic formula now, we get x is equal to minus -4 plus or minus square root of -4 squared minus 4 times a times c over 2 times a. So when I work this out, I'm going to bring it over here to work out. X is equal to 4 plus or minus square root of -8 over 6. And that -8, we have to recognize that the square root of -8 is actually I, and then the 8 is made up, I'll do it this way here, -1 times 2 squared times 2. It's actually 2 cubed, but it allows me to take 1 2 out. So it's I 2 square root of 2. Well, we don't write it that way. Of course, we have to put the I afterwards. So now I have x is equal to 4 over 6 plus or minus. I'm going to apply the 6 to both of these. Okay. So it's 2 root 2 over 6i. Because that, if I take the negative out as the I, then the 8 is equal to 2 root 2. All I have to do now is reduce them. 4 over 6 is actually 2 over 3. And the other one, 2 over 3, and then it's plus or minus square root of 2 over 3i. So the actual solutions, I think I'm going to use this one for the actual solutions. And that's 2 over 3 plus or minus square root of 2 over 3i is 1. And then 0 is another, but it's 0 with multiplicity of 2. Okay, and oops, I didn't want that to go away. So we can't forget about this one here. Get that one, and then we get that, which is simplified. So that's if you're using the common, or if you need to use the quadratic formula, you might get exactly this. Think about the things that we had to do here. Is one of them to use it, and two of them deal with the fact there was an I in it, the negative number, and three deal with the fact there was a perfect square in it, and then 4 deal with the fact that we were factoring. No, on the wrong word, that we were simplifying, reducing the fractions. Okay, let's take a look at a reminder about the difference of two squares. And this is the one where if you have an a squared minus a b squared, it's automatically a minus b and a plus b. And we're looking for these to be perfect squares. Well, here they are perfect squares. We have x that's being squared minus 9 that's being squared. So that means that we can do this. So it's x minus 9 and it's x plus 9 is equal to 0. So they each get their own zeros. So x is equal to 9 and negative 9. Now here, we're going to do the same thing, but you're going to need to recognize that this time there's a 7 and a y together that are being squared. It is equal to 0. Okay. Now this one's not actually, because it has both an x and y in it and only one variable, we're not actually going to solve it. But we are going to practice factoring it. And so we have an x plus 7y and an x minus 7y. The next two, we can actually go all the way to say x is equal to. Hang on. And get the solution set. So for the third one, what we're going to look at is that this can be seen as x squared squared minus 2 squared squared, or 4 squared. So we have then, because of the first set of squares, we can do x squared minus 2. Oh, and minus, well, x squared minus 2 squared. I think I'd like to write that as a 4 because it's easier to think of it than as 4. Okay, so I'm going to go back here to x squared minus 4 and x squared plus 4 equals 0. So in this case, we get x minus 2 and x plus 2. And we're going to make that equal to 0. And then the other one, x squared plus 4 is equal to 0. Here I'm going to subtract the 4. And here I'm going to take the square root, plus or minus the square root of negative 4. We'll come back to that in a second. X minus 2 is equal to 0, so x equals 2. X minus 2 equals negative, or x plus 2. Second one is x plus 2 equals 0, so that means x is equal to negative 2. So here I have one of the answers. Here I have another answer. And here I'm not quite finished because I have to take the negative out, and the square root of 4 is 2. So x is equal to plus or minus 2i. So our solution set for this one. Okay, looks like it's -2, 0, and plus or minus 2i. Okay, whoops. Close that. Okay, now let's take a look at the last one, which is similar. I'm going to first get these shaded in without hopefully losing any of the numbers. Okay. Now, the last one. It's the same idea as the first one. So we want to see this as 1 to the 4th power, or 1 squared being squared. So anyway, I can do this as x2 squared, okay, minus 1 squared. Okay. So we have x squared minus 1 and x squared plus 1 equals 0. I need to keep that for each of them. The x squared minus 1 is x minus 1 and x plus 1. So each of those are equal to 0. So we get x is equal to 1 and -1. Now the other one, x squared plus 1 equals 0, we're going to have to use the imaginary number here. X squared equals -1. Take the square root of both sides, and x is equal to plus or minus the square root of -1, which is I. X is equal to plus or minus I. So what we'll do there is say the solution set is equal to 1, -1, I, and -I. And of course, you could do plus or minus for each of those two. Whoops, I lost the page. There, nope, there it is. Okay, let's take a look at the next page where it's by factoring that we're going to solve. So this first one factors to x minus 4, and x plus 2 is equal to 0. So x is equal to -2 and positive 4. And I'll put brackets around that. On the next one, this one factors to give us x plus 12, and x minus 4 is equal to 0. Say 12, -40, yes it is. So that means x is equal to -12 and 4, and we're going to put brackets around that as the solution set. So that's for basic trinomial factoring. Now let's do it when a is not equal to 1. So when you factor this one, okay, and I'll show the factoring for it. Okay, this one comes to 2x minus 5 and 2x plus 3. And if you need practice factoring, practice that to see that you get these two factors for it. So the 2x minus 5 is equal to 0, and the 2x plus 3 is equal to 0. So 2x equals 5, x is equal to 5 over 2. 2x is equal to -3. X is equal to -3 over 2. Okay, not sure. Well, no, now we've actually got our solutions, -3 over 2 and 5 over 2. We can do the same thing over here, where 8x squared minus 33x plus 4 factors to x minus 30, x minus 4 times 8x minus 1. So these will each get their own zeros. X is equal to 4, x is equal to 1, and then with the 8 being divided on both sides, it would be 8, and so it's 1/8. So this is 1/8 and 4. Okay, now I'm going to take the opportunity to yellow these. Okay, whoops, back again. I'm going to beat it. I'm not going to let it beat me here. Just a little more to do. And on this one too. Okay, now let's look at the next type of factoring that can also be set up. However, if there's x's and y's both in it, then we're not solving it. So this one, I'm just gonna practice factoring it. Okay, and reminding you that how to do this one, you take out the common factor. Common factor, if there's a negative here, you have to take out a negative. And we get x, and that's what changes the sign here. Divide them both by -3, or actually divide both sides, as if we were dividing it. And so we get an x plus 4. This and this are the common factors between these, so we get an x plus 4. And then the other one's the y minus 3. So that's factored, but that's not solved because it has an x and a y. We need only x's for solving. But we're going to apply that now over here for this one. So it looks to me like 2x squared is the right thing to divide into these. That's the common factor, most certainly, okay, for that one. And we have x plus 4. Over here, well, it's a 1 that's multiplied into x plus 4, but it doesn't change anything. So we still have to pull it out as a plus 1, and then the x plus 4. So what we get is 2x squared plus 1 is equal to 0. And then the other one's the x plus 4. X plus 4 is equal to 0. So here, I'm going to subtract 1. Now, not in the plus or minus. -1. Divide by 2. X squared equals -1/2. Now we'll take the square root of that. X is equal to plus or minus square root of 1/2. And remember, square root of 1 is a 1. So x is equal to plus or minus square, or 1 over square root of 2. But we have to rationalize that. Must, always must. X equals the plus or minus square root of 2 on top and 2 on the bottom. Okay. Is there a negative on the inside? Let me actually think about that. Oh, yes, there is. It was -1/2. So good thing I went back to check. Let's look at that. It was a negative here because we had to subtract 1 from both sides to get that, which means this is a negative inside here. Okay, so back to here. That means I need to take, because of that, I need to take an I out. So once I've done that, I don't need the negative in the other things. But I do need to have the fact there's an I here, and then that there is an I in the final. Okay, now it's set. Oh, I forgot to put the -4 in there. Or I didn't quite forget. I jumped ahead here. So plus or minus √2 over 2i. And then there's the -4. Okay. Now, this next part, we can't actually get a solution set for the ones with y's. But what it is to here is practice with doing the cubes. So this one, we can't actually get a solution set for, but we can with the other ones. So let's do that. This is where you recognize the formula for it. Because that one's plus, we're going to be using this one. You just have to identify what it is that's being cubed. And for some of the numbers, just use a calculator to try the different ones. until you find which one's cubed for it. Okay. So this allows me to do 2x plus 7, and then 4x squared plus 14x. Oh, not plus, but minus, because of where the minus goes when the first one is plus. Minus 14x plus 49. And all that's equal to 0. So the 2x minus 7 one can be done as, that's going to come out to x is equal to negative 7 over 2. This one's going to be a plus or minus, so use the quadratic formula, which actually I haven't done for this one yet. So let's go ahead and do that. Okay. So A is 4, B is negative 14, C is 49. Okay, so x is equal to negative b. Okay, so minus a negative 14, 14 years old there. Okay, negative b plus or minus square root of b squared. That's 196. Minus 4 times a times c. And all of that over 2 times a. Okay, so I'm going to take a look here. Okay, I'm going to make sure I had 4 squared, which is 16, minus all the other things. Minus 4 times a times c. So let's continue this one over here. X is equal to 14 plus or minus. And inside, we get, we're going to have numbers here. Let's see what I can do with it. 4, okay. So what we get is 14 plus or minus square root of 768 over 8. Okay. And let me check a couple of numbers. So 16 can be taken from this. So let's see what happens. 17. There's even more. So I'm breaking this down for myself. We have perfect square of 16. And I think maybe even more. Okay. Looks to me, I believe, it's the 8 divided by 12, that will do. Some more. Oh, by 144. No, okay. I'm going to do this one in parts here. That one's 14 plus or minus. So we can do 64 times 70, 60. Let's see, 60. No, hold on. Let me, this. That's 64 times 12 over 8. That's an 8 that comes out. So here we get 8 square root of 12. The square root of 12 has a 2 in it. That's actually 4 times 3, so I can put a 16 there. So that's actually 16 square root of 3. Okay, so I'm going to take a little bit of space of this next one here. Okay, maybe I'll go here. 14 plus or minus 16 root 3 over 8. So we have to do 14 over 8 plus or minus, well, 16, that's 2 root 3. 16 over 8 is 2. And 14 over 8, I can actually do some changing right now. That's 7 over 4. So I'll leave it as 7 over 4. So our solution set includes 7 over 4 plus or minus 2 root 3. And it was a negative. Let's see, that should have been a negative here and a negative here. So that means there's an I in it. 2 root 3I. And this one over here. negative 7 over 2. Now I took up some of the space that's in the next problem, but what's good about that is that one can't be solved. It can just be factored because it has a y in it. So let's actually do this one. That's going to be 10x cubed, because 10 cubed is 1,000, plus y cubed. So we can do 10x plus y times 100x squared, plus or minus now, as 10xy plus y squared. We can't do equals 0 because we have an x and a y in it both, and so we can't be solving this one, but this is good practice factoring with it. On the next couple here, this one's going to get us with an I in it, but this other one won't. Well, actually, let's work it out. Okay, so here I have x plus 5, and because that's 5 cubed, and x squared minus 5x plus 25 equals 0. So we know we have x equals negative 5 here. And on the other one, if I can factor that with a negative 5, negative times negative, I believe that's x minus 5 times, no, it's not. It can't be. We're going to have to use the quadratic formula. So x is equal to negative b plus or minus, so it's minus a negative 5. Negative 5 squared is 25, minus 4 times 1 times 25 is 100 over 2. So x is equal to 5 plus or minus square root of negative 75, all that over 2. So that means I'll immediately take that I out. And 75 has perfect square in it of 25 times 3. So that 25 times 3, that means a 5 comes out. 5 plus or minus 5 root 3. And then I'll put the 2 underneath both of these with the I. So this is the result of the quadratic formula. And there's that, and the negative 5 as my solution set. Okay. On the last one, I'm going to do the same thing here. We've got 3x that's being cubed minus 1 that's cubed equals 0. So I get a 3x minus 1, and then 9x squared plus 3x plus 1 equals 0. So here I'm going to get that x is 1/3. And over here, I'm going to need to use that quadratic formula again. X is equal to negative b plus or minus b squared, which is 9, minus 4 times a, which is 36, times c, which is 1. So we'll do a 36 here. Okay. Now over 2 times a, so it's 18. So let's work with this part here. That's the square root of negative 25, 26, 36. No, let's see, 29, that would be 11, so it's 27, unfortunately. So that means we're going to take an I out immediately. And the square root of 27 has a 9 times a 3 in it, so it's 3 root 3 I. So x is equal to negative 3, and I'll just put it over 18 first right now, plus or minus 3 root 3 over 18 I. That's the result of the Pythagorean theorem, and then we'll put the 1/3 from the other part. And that is our solution, where we have solved it using the second degree polynomial from the formulas for a sum or difference of cubes. Very important to get those formulas down for these problems. Okay.